in this video, we're talking about confidence intervals, and instead of estimating the mean, we're now going to estimate the population proportion, and we will be using our Rgruoo. So for confidence interval proportions, the setup is still the same. We still take the point estimate, add and subtract the margin of error to find the confidence interval. The difference is that the point estimate is no longer the sample mean, it's a sample proportion. And so the sample proportion, I mentioned in a previous video, is P with a caret on top. We call that P hat. And to find that, you just find the proportion that's in the sample that has the desired outcome. So how many of the sample have the desired outcome? That goes on the top out of the total in the sample. We will be using the normal distribution for this. So when we do our critical value to find the margin of error, that will still be a Z. But our standard error has to be different because obviously we're not dealing with standard deviations and all of that. That won't be listed in the problem. So there is a formula that you use for standard error for this type of problem, and it's the square root of P hat times Q hat over N. Now we've talked about Q before, so Q hat is similar. Q is the complement of P, so Q hat is the complement of P hat. So to find Q hat, you do 1 minus P hat. Okay, so here are the things that we need to note. The sample size is N. The number of people who respond in the desired way is X. The sample proportion, P hat, is X over N. And then we're assuming the sampling distribution is normal with P, the true value, and the standard deviation, with the mean P and, the true value and the standard deviation of the standard error here, which is square root of P hat times Q hat over N. And we assume that the population is at least 20 times larger than the sample. And the sample contains at least 10 people in each category, yeses and nos. All right, so the formula looks a little bit different. It's still, if you look, it's still the point estimate plus or minus the margin of error. The margin of error is always the critical value times the standard error. So in this case, the point estimate is P hat. The critical value, we're going back to using the Z distribution, so the normal distribution, and then the standard error, instead of sigma over square root of N or S over square root of N, it's square root of P hat Q hat over N, like this. So this is the formula that we will be using for this section. All right, so let's look at an example. The Nielsen Company surveyed 25 owners of Android phones and found that 160 of them plan to get another Android as their next phone. Construct a 95% confidence interval for the proportion of Android users who plan to get another Android. So we're doing a confidence interval for proportion. So that's all we need to know. It's not for a mean, it's for a proportion. And we're going to use this formula, P hat plus or minus Z alpha over 2 times the square root of P hat Q hat over N. So what is P hat? P hat is the number of people that answer in the desired way. So how many plan to get another Android? It'd be 160 out of the total 225. What you'll notice is that X is always smaller than N, and it looks like my screen there got it froze up and then it stopped, so bear with me 1 second. All right, got it back there. Okay, our Z has to do with the confidence level. Confidence level is 0.95. If we've got 0.95 here, you got 0.025 here, 0.025 here. We're going to get a Z of 1.960. I know that because we've done 95% quite a bit, but I'll just remind you, if we go to probability simulation on our Rgruoo, probability calculator continuous, choose probabilities to values, it should stay normal. We'll do between tails, and we're doing 0.025 on either side. we get 1.96, right? Okay, so back here, um, I'm going to figure out, I'm going to use the calculator here in Rgruoo and see if I do 160 divided by 225, I get 0.711111111 repeating. So I'm just going to do this as 0.7111. If you can use the fraction in the formula, that's actually the better thing to do because you don't have to round within the problem. But if you are going to round, I would say go out to at least 4 decimal places. And then if I were going to do Q hat, I need to know Q hat. That is 1 minus P hat. So 1 minus 160 over 225. So 1 minus 160 over 225. And we get 0.2889 if we were to round to 4 decimal places. All right, so I wrote those down. N is the sample size, which is 225. All right, and I think we have everything now. All right, so using the formula here, we've got P hat, which is 0.7111 plus or minus the Z, which we said was 1.960 times the square root of 0.7111 times 0.2889. And you can replace those with the actual fractions instead, divided by n, which is 225. So I'm going to go straight over to Desmos. And I'm going to do 0.7111 minus 1.960 times the square root. And then I'm going to do 2 parentheses here because I need to have the whole fraction be underneath. All right, so first I'm going to do 0.7111 times 0.2889, and then go outside of that parenthesis, divided by 225. And we get 0.6519, 0.6519. So I'm going to go and write that down. And I'm going to do this again, but I'm going to go and change it to a plus sign. And we get 0.7703. All right, so if you were to write this as a sentence, you would write, we are 95% confident that the true, instead of mean, we're going to say proportion. And in context, we're going to say of Android users who plan to get another Android is between 0.6519 and 0.7703. And then just to help you understand what this is really between 65.19% and 77.03%. That may make it make more sense to you than having it in the proportion form. So it says, assume that an advertisement claimed that 70% of Android users plan to get another Android. Does the confidence interval contradict the claim? Well, if you look in between here, 70%, which is 0.70, falls within the confidence interval. So, no, it doesn't contradict. It agrees because 70% is within the confidence interval. I'm going to put CI for short to make it a little bit quicker. And looks like I lost my screen again. 1 second. All right, looks like I got it back, but it looks like the screen is a little bit smaller. All right, so obviously this formula is a little bit crazier than the earlier ones. It's once you fill it in, it's not a big deal, but it does have a lot of pieces. So using Rgruoo as a confidence interval calculator is very helpful. So to do this, you go to the analytics tab just like you did with the mean confidence intervals, and you choose proportion inference, which is above mean inference. And you choose one population just like we did before, but again, choose proportion inference this time instead of mean inference. Once you do that, you're going to enter your data manually. So for manual entry, you're going to enter the sample. So everything's going to be on the right here. So you're going to enter the sample size. You're going to enter the number of successes. This is your X. The number of people that responded in the desired way. So sample size in, this is X right here. I'll write that down. This is N, this is X. All right, you're going to put those in. Now, what you need to do is you need to label what those are. So the factor, you're going to name the population. The success is what you can consider a success. You don't have to label a failure unless you want to. Once you put in the sample size and the number of successes, the proportion of a success will, right here, that will automatically populate. Um, and you want to make sure that this is labeled here. That's your success label. And you're not going to do anything with the test of hypothesis yet. We're just going to focus on confidence interval. So you want to enter your confidence level, and then you want to check large sample Z, and then you'll click the eyeball, the preview. So if the number of successes is unknown, you would use this formula here to figure out your X. Your number of successes, it's p hat times n. I'm going to highlight it instead because my box was covering up the little hat there. All right, so let's look at an example. According to the U.S. Bureau, 43% of men who worked at home were college graduates. In a sample of 500 women who worked at home, 162 were college graduates. Construct a 98% confidence interval for the proportion of women who work at home who are college graduates. So N is the sample size, that's 500 women. And of those, the X is 162 are college grads. Okay, and we're doing a confidence level of 98%. So again, you can use the formula, but it is definitely quicker to go into Rgruoo and put this in. So let's go do that. Let's go to Rgruoo, and we're going to do probabilities. No, I'm sorry. We're going to go to analytics, click on analysis, proportion inference this time, one population. And then we're going to put in our sample size, which was 500, and the sample represented women. And then the number of successes were 162 were college graduates. And if you'll notice down here, the P proportion of college graduates fills in right here. If you look here, the proportion of a success is filled in as well. So this is actually your P hat. Your P hat is 0.324. If you wanted to label, you could label a failure as non-college graduates, but you do not have to. We are doing a 98% confidence interval, so put 0.98 and click large sample Z. And here we go. Now, at the top, you'll see the little table has your counts. So how many were college graduates? how many were not college graduates. So 162 are college graduates, 338 were not. The total is 500. And then they translate each of these to percentages. So 32.4% were college graduates, 67.6 were not, for a total of 100%. The confidence interval itself, it shows the method is a large sample Z. That just means that's what we clicked. It gives you the midpoint, which is the midpoint of the confidence interval, which happens to be the point estimate, which is p hat, which we already said was 0.324. And it calculates the standard error. So if we did the square root of p hat times q hat over n, that's what you would get there. And here's the lower and the upper boundary. So this is really what's important, these two numbers there. So it's between 0.2753 and 0.3727. The width, this would be your margin of error, is right here. So it calculates all of that for you. So going back here, we did all of that fairly quickly. And then we would say we are not, 43% confident that the true population proportion of women who are college graduates. And did anybody see where I messed up there? I'm going to just finish the sentence and then I'm going to correct it. Is between 0.2753 or 27.53% and 0.3727, which is the same as 37.27%. And what did I mess up right here? 43%. That was the percent of males who worked at home who were college graduates. Honestly, the women, it's not just women, it's women. I need to add this in here. Oops. Women who work from home who are college graduates. I left that part out. Anyway, so we are, and then this was what I messed up. I'm going to put it in a different color. It should have been, and I just lost it again. It should have said 98% confident. All right, there you go. You can see I just filled that in. I'm not sure why I keep losing the screen. Technical difficulties here. Anyway, it said at the bottom of the question here, is it reasonable to believe that this is the same as the proportion for men? So look at the proportion for women. It's between, this is basically between 27.53% and 37.27%. What percent of men who work from home are college graduates? 43%. This is definitely lower. The whole confidence interval that is estimating the true proportion of women who work from home that are college graduates is somewhere between 27.53% and 37-ish%. That whole thing, that whole estimate is below 43%. So it is not reasonable because the confidence interval estimates the proportion of women sorry, just rewrite this. The proportion of college grads for women who work from home to be less than 43% because the entire confidence interval is less than 43%. All right, here we go. It's example 3. An internet service provider sampled 540 customers. So I'm going to go ahead and label that 540 internet customers and found that 75 of them experienced interruption. Oops, I think I misspelled interruption. Try this again. During the previous month, construct a 90% confidence interval for the proportion of all customers who experienced an interruption. The company's quality control manager claims that no more than 10% of its customers experienced an interruption during the previous month. Does the confidence interval contradict this claim? So we're doing a 90% confidence interval for a proportion. So we're going to come over here to analytics. We're going to click on analysis, proportion, inference, one population. We're going to put the sample size is 540. Oops. And it's 540 internet customers. So you have to make sure you label it. All right. And then the success is 75 experienced interruption. And you can see the proportion of success has been filled in here. The confidence level should be 90, so 0.90, and we're going to click large sample Z. And we get a lower boundary of 0.1144, so 11.44%, and 0.1634. Okay. So going back here, we would say we are 90% confident that the true proportion or population proportion of internet customers who experience disruption, or I think it was interruption, is between 0.1144 and 0.1634, which is roughly between 11.44% and 16.34%. So when the quality control manager says no more than 10%, is this no more than 10%? No. It is above. The entire confidence interval is above 10%. So the quality control manager is wrong, and they need to revisit some things about their internet to hopefully make their customers have a satisfying experience with their internet. All right, let's do another one. Health insurance. So I know you may have noticed we're going straight Rgruoo with this. You can still use the formula, but this formula is pretty lengthy, so I really do like using Rgruoo here. In 2008, the General Social Survey asked 182 people whether they received health insurance as a benefit. So there were 182 people. That's my N. And X is the number that answered in the desired way. So 60 people said they received health insurance. All right. Construct a 95% confidence interval for the proportion of people who have received health insurance from their employer. So going here again, we're going to go to analytics, analysis, proportion, inference, one proportion. The sample size was 182. And to label that, that is just 182 people. And then of those, 60 received health insurance. So you want to label that. You can see the proportion of the success is 0.32967 for the PHAT. Confidence level is 0.95. Click large sample Z and then preview. And here's our answer here. We get somewhere between 0.2614 if you round and 0.39796. That rounds to 3980 if you round it to 4 decimal places. So our sentence, we would say, we are 95% confident that the true population proportion of people who receive health insurance from their employer is between 0.2614 and 0.3980. So between 26 and almost 40%. I don't think it asked any other questions. You just said construct the confidence interval. All right, so just like when we did the confidence intervals for the mean, I showed you how to find a sample size if you wanted a specific confidence level with a specific margin of error. Because as you know, the larger the confidence level, the bigger the margin of error, the wider the confidence interval. And we want to have those confidence intervals be narrower. So the way to combat that is to have a larger sample size. So if you want a sample size large enough, you need a formula. So the formula we had before, this is for confidence intervals for mean. You would say n equals, it was z alpha over 2 times sigma over the margin of error squared. And then we rounded it up to the next integer. But if you're doing, if you're calculating a sample size to estimate a proportion, you need to use a different formula. And so we actually have two different formulas. One formula we use if we know p hat, and the other formula we use if we don't know p hat. So normally we are not going to know p hat, so we're normally going to go with this formula right here. But just in case, we do have this other formula if need be. So the difference is, if you know p hat, you multiply the critical value over the margin of error squared times p hat times q hat. If you don't know p hat, basically what happens is you assume that p hat and q hat are both 0.5, and 0.5 times 0.5 is 0.25. But this is the one we normally are going to use. Let's do an example. Suppose a polling company wants to ensure that their next political poll has a margin of error of 3. All right, points or less, using a 95% confidence level. How many voters should the company poll to make this happen? So we know the margin of error is 3 percentage points, 3%. And if we're doing 95, and you have 0.025 here, 0.025 here. If we do our probability calculator and do probability to values and do between, and we put in the lower tail of 0.025 and the upper tail of 0.025, we get a critical value of 1.960. And I just shortcut that real quick just because we've done 1.960 for 95% quite a bit. So you may be memorizing that now. All right, so since we're trying to find how many voters should the company poll, that is another way of saying what sample size is needed. We're looking for N. And because we're doing, this is for a proportion. So does it tell us this is for proportion? Is it suppose a polling company wants to ensure that their next political poll has a margin of error of 3 percentage points or less? Use a 95% confidence interval. How many should you poll? Because we're dealing with a margin of error of percentage points, that also notice they don't talk about estimating a mean. They don't mention standard deviation at all. That's kind of your clue that this is for a proportion. So we don't know the sample proportion, so we're going to use this formula. And we actually have all of that. So we have 0.25 times 1.960 over, here's the thing, if they say 3 percentage points, you put 0.3 and then squared. If you're doing this by hand, you want to do the 1.960 divided by 0.03 first, then square that, multiply by 0.25 last. If you're doing this in Desmos, we would just do 0.25 parentheses 1.960 divided by 1.960 divided by 0.03 for 3%. And then outside of that, we're going to square it. And we get 1067.11111. And then, if you'll recall, you always have to bump it up no matter what. So this is really 1068. So the company should poll 1,068 voters in order to have a margin of error that is 3% or less. All right, so just to summarize what we've learned for confidence intervals, you have really three options. We had three formulas. We had a formula for, let me add in the square root signs. Those sometimes fall off here. Okay, so we had this formula here, and this formula here. When do we use each? So the first thing you need to do is which parameter are you estimating? Are you estimating a population mean or population proportion? If you're estimating a population proportion, look for your standard deviation. Do you know the population standard deviation? So this is population standard deviation. Or do you know the sample standard deviation? If you know the population standard deviation is considered a Z interval, you would use this formula here. And then if you were doing Rgruoo, you would do analytics, you would choose mean, inference, one population, and just make sure you do a Z for your statistic. If you know sample standard deviation instead, you use this formula using the t distribution for your critical value. And in Rgruoo, you would choose mean, inference, one population as well, but again, you would choose t this time. If you're doing a confidence interval to estimate a proportion, you use p hat plus or minus z times the square root of p hat q hat over n. If you're doing it in Rgruoo, you do a proportion inference for one population. And that's basically it on how to decide. If it's a confidence interval for a mean, you just have to look at your standard deviation and figure out which one they give you. And if it's a proportion, you just do the proportion inference instead. The other thing that that I did a little flowchart for is sample size. Which formula do you use? So if they ask what sample size is needed, or how many people should be surveyed, or how many people should be in a sample, there's 3 formulas to choose from. You need to pay attention to whether the goal is to estimate have a confidence interval to estimate the mean, or a confidence interval to estimate the proportion. So if you're constructing a confidence interval to estimate the mean and you want to know the sample size needed, you use this formula, which is the critical value z times the standard deviation divided by the margin of error squared, and you want to make sure you round up to the next integer. If your goal is to construct a confidence interval to estimate a proportion, you have to decide whether or not you know p hat or whether you don't know p hat. If you know p hat, it's p hat q hat times the critical value over the margin of error squared. If you don't know p hat, it's 0.25 times the critical value over the margin of error squared. And again, round to the next whole number. You got to round up. And that is everything for this section. If you have questions, let me know.